dear students. I'm Dr. Vaishali Bharambe. I've been teaching anatomy for a long time. And today I have come to you with an interesting inheritance, X-Linked Recessive Inheritance. I know many of you find these lectures very challenging. Okay? My suggestion to all of you would be take a piece of paper, take a pen, and then learn it as I teach it. Okay? Don't try to mug up these points. It's not humanly possible for all of us to mug up these points. Sit with a pen and paper and see how well you will learn. Ready? Okay. I want to start with this sheet which is having some basic terms. Whenever you feel that you're not understanding some term I'm using, you can come back to the screen and just brush up on the basics. Students understand that genetic disorders are subclassified into chromosomal disorders, single gene disorders, mitochondrial disorders, and so on. Chromosomal disorders I have already taught, lectures for which are already available on YouTube. Link is given in the description section. Today we're going to talk about single gene disorders. Disorders that are occurring because of abnormality in a single gene. So, disorders caused by a single gene. We can understand that single gene disorders follow a single gene or unit factorial inheritance, which is basically what Mendel taught us. Okay? So it is a single gene inheritance, further subclassified into whether the gene is attached to an autosome or a gene is attached to a sex chromosome. So subclassified into autosomal inheritance, sex-linked inheritance. Autosomal inheritance will be determined by whether the gene is dominant or recessive. Okay, so that is further subclassified into dominant and recessive. Sex-linked is classified on whether it's attached to X chromosome or Y chromosome. So X-linked and Y-linked. Further subclassified into X-linked dominant, X-linked recessive. Got it? Now, today we are going to talk about X-linked recessive disorders. What does that mean? That the mutant gene is on an X chromosome and it is recessive. It will only express itself when they are in homozygous state. Singly, it will not express itself. Is that clear in your mind? That is basic. You have to know this to move forwards. Okay? Fine. So, I want to bring some facts about males in front of you. Now you're suddenly interested. What is ma'am saying? No. This is purely based on genetics. Understand that males have only one X. Males are said to be hemizygous basically. So what will happen? Anything which comes under X-linked inheritance will always be expressed in the males. If the males had 2X, then there would be option कि भाई इसको express करना है कि नहीं करना है. But in this case, there is only one X in the males. So whether it's X-linked recessive or it is X-linked dominant, in the male, it will always be expressed. So the males always suffer in case of X-linked disorders. Funny, isn't it? X is supposed to be related to females, but it's the males who suffer from it. That's life, right? Understand that a father passes Y chromosome to his son. Does he pass X to his son? No, he passes X to his daughter. So X-linked inheritance passes from father to daughter. Can it pass from father to son? Never. Okay? So no father can pass an X-linked disorder to his son. He can pass it to his daughter. Fine. Y-linked disorders therefore pass from father to son and never to daughter. So what's the meaning of this sentence? Father passes Y to his son. So Y-linked disorder will always go from father to son. Can it go from father to daughter? No. These are basics. I expect all of you to understand these things because now in the subsequent coming lecture, you will be facing the situations like this. What about females? Do we have to know some basics about females? Of course. Females have 2 X chromosomes. But, what is the but I'm talking about? Yes, you remember I've taught you something called bar body, I've taught you something called Lyon hypothesis. Yes, so only one is X is active anyway. Okay, so she may have 2 X's, but only one will be functional. So that will affect the expression of the disorder. In a heterozygous female, it's a matter of chance whether her normal allele or her mutant allele is expressed in that cell. Okay, think about this. Right. So we come for the topic of the day, which is X-linked recessive inheritance. Examples are, I've given you 5 examples: hemophilia, G6PD deficiency, testicular feminization syndrome, Duchenne's muscular dystrophy, partial color blindness. Again, be kind. Create a mnemonic. He got to draw peacefully. He, hemophilia. G, G6PD deficiency. D, Duchenne's muscular dystrophy. 2, testicular feminization syndrome. Peacefully, P, partial color blindness. Use mnemonics to help yourself remember. Don't be unkind and have some outlandish expectations from yourself. Not fair. Okay? Treat your brain the way you treat the rest of your body, with kindness. Right. So X-linked inheritance, some basics. It's a recessive disorder, so expressed only in homozygous state. Now write this down. X, H, X, H. Write it, all of you. Write this X, H, X, H. That means 2 X chromosomes with the homozygous state. So in females, what happens? Females have 2 X. Females are rarely affected by the disorder. Heterozygotes are always carriers. So X, H, X is always going to be a carrier. Let's put the male in this place. In the male, even if the person is XHY, he is affected by the disorder. Can you tell me why? Why is he affected and the woman in XHX state is not affected? Okay, because she's got a homologous X chromosome with the dominant allele on it. In this case, there is no parallel X chromosome at all. So whatever is there has to express itself. Basics. Right. So let's consider an example. बहुत ज़्यादा मैंने डाल दिया. I know you're getting confused. हम लोग एक example लेते हैं. Cases of hemophilia. The disease is hemophilia. Who can suffer from hemophilia? The female who is XHXH or the male who is XHY. What about female who is XHX? Can she suffer? No. What does she become? She becomes a carrier. Look at the screen for a minute. Put it in your brain. Who is affected female? Who is affected male? Who is carrier? Get these fundas clear. Then only we can go ahead. Come on, take a look. Clear? Chalo, let's go ahead. So now, you know that there are 2 people who are affected and there is a carrier state. Let's begin to understand how from these affected people, okay, you can have progeny who are affected by the disease. This is a problem. Just imagine if the mother is suffering or father is suffering from hemophilia, a clotting disorder, okay. They will say, Bhai, doctor, we've suffered from this, okay. What is the chance of my child suffering also? I don't want my child to suffer, okay. Now you have to sit down and think, what are the chances of this parent passing this disease to his or her offspring? Let's understand. Right. So now, how do we remember which parents to cross with each other? Okay. So take a carrier. Let the carrier marry a normal male, a affected male. Take a affected patient. Let that female marry a normal male, an affected male. And finally, let the affected male marry a normal female. इतना याद रखो, बाकी सब आराम से आएगा. No problem. So, like I said, get a carrier female to marry a normal male. What happens? Take a look. Come on, start working it out in your Punnet squares in your sheet. Don't look at the screen. It will not fetch you anything. Write it, work it out. You will develop the answer on your own. So, when the carrier female marries a normal male, one female child is a carrier, other female child is normal. One male child is affected, one male child is normal. So what do we say? Half the children are normal, half the daughters are carriers, half the sons are affected. This is what happens when a carrier female marries a normal male. Okay, did you see how the carrier female landed up giving birth to a affected male? Right. When a carrier female marries a affected male, what happens? Work it out, come on. So, half the daughters are affected, half the daughters are carriers. Half the males are affected, half the males are normal. Did you understand what we did? Okay. This answer is coming from my Punnet square. I am not creating the answer. It's coming from my Punnet square. It's giving me the answer. And that's the only way you should get your answers. Now let me marry an affected female to a normal male. What will happen? All the daughters are carriers. All the sons are affected. Did you see how from the mother the disease passed to her son? Her daughters became carriers, but the sons became affected. So, disease passes from affected mother to affected son. Let's have a similar situation where the mother is affected and she marries a affected male. This happens in life. When two people are suffering from same disorder, कोई उनसे शादी नहीं करता है, they'll end up making a family of their own. Then what will happen? All children are affected, all daughters are affected, all sons are affected. Got it? Disease has passed from affected mother to her son and daughter. Disease has passed from affected father to his daughter. Can he pass it to his son? No. Why not? Because he never can give an X chromosome to his son, to whom he must give his Y chromosome. Finally, if there is a normal mother and an affected father, what will happen? All daughters are carriers. All sons are normal. So, what is the bottom line here? Disease passes from affected father to carrier daughters. Okay? So, these are all the Punnet squares that we saw earlier. You've developed them. Okay? So, you see that from a carrier mother, the disease results in more carrier females. But who is affected? The male is affected. The affected male then results in development of carrier females. Are you seeing that? Carrier female, affected male. Carrier female, affected male. It's the males only who are getting affected, not the females. Females are carriers. However, when the affected male marries either a carrier female or an affected female, suddenly there are affected females formed. Which is more likely to happen in the same community? What is the chance of your suffering from a disease and your partner having the carrier status for that disease? It's very, very small chance unless you marry in the same community. Consanguineous marriages. All recessive disorders always have some kind of history of consanguineous marriages. Okay, so you saw how when the father is affected and the mother is a carrier, suddenly there is one female child who is affected by the disease. Again, in this case, when both parents are affected, all children are affected by the disease. Fine, we've done a lot of permutations and combinations. What is the commonest thing that happens? The commonest thing that happens is the mother is a carrier, she marries a normal father. किसी को कुछ मालूम ही नहीं रहता है. Girl doesn't know she's a carrier, father doesn't know she's a carrier. They go ahead, they get married. What happens? I've already told you. The daughters become carriers, but the son becomes affected. Suddenly they feel, हमको तो कुछ हुआ ही नहीं था, how come our son is affected by the disease? Right? This is because of the carrier status of the mother. Now what happens? This carrier mother marries another normal male. Carrier daughter marries another normal male. Again, carrier female, affected male. This affected male then marries somebody, maybe a normal female, and then again he passes it to his daughters. So daughters are becoming carriers. Have you seen now what is happening? Carrier female affected male, carrier female affected male. That is how the disease is transmitted. It is rare for females to actually suffer from the disorder. Males are affected by the disease transmitted by carrier females. Right. So, some characteristics. It's an X-linked recessive trait, mostly is seen in males who are affected and women who are not affected. In females, usually a carrier status will be seen. The trait is transmitted through these carrier females. So, how can we put it? The affected male gives it to his carrier daughters, who then give it to his grandsons. You got it? Male to female to male. Okay? Over 3 generations. I'll show you in a pedigree chart, you will understand. Trait cannot be transmitted from father to son. I've already told you, father never gives a X chromosome to his son. The healthy sons or daughters can never transmit it forward. By healthy, what do I mean? Homozygous unaffected parents can never pass it forward to their offsprings. Affected female may not transmit the disease any further because she may just die. Especially in case of hemophilia, she may just die, so there's no question of passing it forwards. Fine. So let's look at this pedigree chart now. Can you see it round with black dots on it? Each of these is a carrier status, and jet black, these are affected. Now take a look. A carrier woman gave birth to an affected male, who passed it to his carrier daughters, who gave birth to an affected male. This is called as oblique transmission. Okay, what is it called? Oblique transmission or diagonal transmission. Female, carrier female affected male, carrier female affected male. This is how it goes. Diagonally. Okay, so that is typical feature of X-linked recessive disorder. Okay, you need to revise this lecture a couple of times to actually be able to write an answer on it. Trick is to remember to marry whom to whom. You're like running a marriage bureau. You're going to marry a carrier female to a normal male, carrier female to an affected male, affected female to a normal male, affected female to a carrier or to affected male. This is how you have to marry them and create various features of X-linked recessive disorders. Hemophilia follows following type of inheritance. Obviously, X-linked recessive. MCQs in this field are based on purely on your amount of revisions that you will do. There is no way you're going to have some logic to X-linked recessive, not where disease names are concerned. So unless you revise, you're likely to miss out on these MCQs, which are very commonly asked. Okay? Right. So students, if you like this lecture, do like and subscribe to my channel. It will encourage me to create more of such videos to help you out in your day-to-day studies. I've also recently made a series on videos on how to handle theory exams, how to handle vivas, how to study anatomy. Do please go and watch those as well. They may help you in the challenging subject of anatomy. So I'll see you across the screen in some other video. Bye students.